Hi everyone, welcome to Sachii Online Academy. This is Sachii. Today I'm going to take you through this tutorial where we'll be finding the mode of given numbers. This question was actually given it to me by some students at Bindra University, but I failed to do it in time just because I was also busy preparing for my exams. But today I've got to find some time just to do this video for you team. So in this video I'm going to explain how to find the modes using in Java using the linked list data structure, and I'm also going to give you the code that you are going to use. So in this I'm also going to define what is mode in statistics, and also the algorithm that you are going to use. So here in statistics, the mode is a value that occurs the highest numbers of time, or it is the number that appears more than any other number in the list. The number that appears more than any number in the list. For example, we can have this list of number just like this. Let me call it set A here. We can have this set A. If you want to find our mode here, we will find the number that we've got the highest number of occurrence in this list. Like here 2, you have got two number of occurrence. This one is 1 and this one is 1. So here our 2 is what? Our 2 is our mode. That's how we have to find our mode. So the algorithm is here. The first step of our algorithm is to take an integer set A of any values. We have to take the integer set A of any values. Like here we've got this set A of what? Of any values. 1, 2, 3, 4. It is a set of what? Of 4 values. That's the n here. So this is our set 2, 5, 2, 2, 5, 6. That's our set that we actually want at the first step, and then we have to store it in our linked list data structure. I've chosen this linked list data structure because the question was required us to do what to find the mode using the linked list data structure. So also it was actually required us to use the find mode method, the separate method from just outside the main method. So here on step number 2, we are going to use we are going to use the count variable to count the occurrence of each integer value in A. We have to count the occurrence of each integer value in what in our set A. In our set A, like here, we have to count the occurrence of each and every value. Like 2 is actually appearing here in this list 2 times, and then this one time, and this. That's what we have to do. And then from there, we have to display the value with the highest occurrence. Like here, 2 have got the highest value of occurrence, and then we display that this 2 here is our mode. That's the algorithm that we are going to use. And then I'm going to give you an example. I'm going to rotate what my board, and then after that I'm going to show the code that I've already done for you. So here team, we've got this method that I've already done for you, where you have to find the mode of given numbers using the linked list data structures as it was required by the question. So I've got actually created this find mode class as it was required by the question, and then from there I've got this static void, the main method, where I actually have to call the find mode that was also required by the question to do. So we've got the system.out.print line method, where we are going to print this string, the mode is, and then from there I'm going to append this number which is going to be retained by what by our method, which is the find method here. So this method will return an integer, since it is declared as int here. So it is going to return an integer. That integer is going to be actually appended to this string, or a string concatenation. So the mode is blah blah blah, according to the number that is going to be retained by this method. So state int find mode. This is a method that I've actually declared outside the what? That I've actually declared outside the defined method here, outside this outside the main method, sorry. So this method, how is it going to work? First, I'm going to declare these variables that I'm going to use. The max count variable, which is actually that I initialize it to 0, and this mod and this count variable. This max count is going to actually store the previous values of count, so that we can keep track of the record of the number that we have got, what the highest occurrence in our list. And then this mod is going to actually store the actual value, or the actual value, which is the actual mod. And this count is going to actually count the what, sorry for the background noise. This method is going to, but I don't have the appropriate place to do these videos, but I actually want to help you, so I try my best to do these videos for you team. So this count method is going to store the number of occurrence of each and every value in this list, but we set it on each and every loop. So we will use this count, this max count variable, to keep track of those values that will be lost, that will be lost on each and every loop. So at first I've actually used an array, so that just because I don't want to take the input from the user, since the input was already stated on the question. So I have to declare an array of these numbers, and then I'll shift them to the list, just like that, so that I don't have this method. They've got the method that we have in LinkedList data structure of adding the elements to or the objects to the LinkedList data structure. So instead of just having here of what 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, instead of writing 14 lines of this, repeating this, I've actually used 1, 2, 3, almost 3 lines, only 3 lines to do that. So here I'm going to take all these elements of this array and put them in our linked list data structure. So here I've actually declared this linked list data structure here using linked list list, which is equals to new linked list, the new object of linked list data structure. Here guys, you have to import this linked list data structure. You will get an error if you didn't import. You have to import it first here, the linked list data structure, so that you can use it. So here, this is the for loop. I'm going to use the for loop to take all the values from this array and then put them in this list. This is the object that I'm going to use, that I've actually created. So I'm going to use this add method in we have got the add method in linked list data structure, which is this add method. There's this one with the index, and then we put the object here. This is the method that we are going to use to add the elements to the linked list data structure. This is the predefined method. It comes with the Java. So list.add, here this k is this k, where this one will be keeping track of the index, of this linked list. Also, it will keep the index of the array. Like here, initially our k is equal to 0, and the k will be less than this number's dot length. We've got the dot length method. We've got the length method in an array where to retain the number of elements in this array. So at first, our k will be equal to 0, and then at index 0 we are going to store the element of an array which is at index 0, which means we are going to add 2 as our first element of this list. And then when k is equal to 1, because we are going to increment k on our for loop here, k plus plus. So our next loop, our k will be equal to 1, and then when k is equal to 1, this one here at index 1 we are going to store the element in our array at index 1. So up to this, maybe it's index 14 or what. then we put this 21 here in our list, and then we terminate this for loop here. That's where we terminate this for loop here, from here, from where? From here up here. That's our first for loop. And then from there we've got the second for loop, but here this is the algorithm that you are going to use to find the mode. Because here we are now having our list here, actually initialized with what? With our objects that we want to, or with these numbers that we want to find what? The mode from. So here we've got the nested loop. We're going to use the nested loop for loop team to find what? To find this mode. So how are we going to achieve this? We are going to use almost 3 methods that we are going to use, which are actually already predefined in our Java library. So we've got this list method and this equals method, and also the get method that we are going to use. These are methods that already comes with what? With the linked list data structure. So here we are going to use this size method, which will return the size of the linked list, or the length, or which is the size of the linked list, or the number, or the number of elements in our, or the number of objects in our linked list. So here we are going to start with this is the outer loop team. So this outer loop will actually we are going to keep this I as a constant in the second inner loop, or in the nested inner loop, this for loop here. So on each and every loop of the outer loop, we are going to reset count to 0. Why? I'm going to explain to you. So this inner loop, in this inner loop, we are going to hold this one I, to hold this one I as what? Is constant in this loop, and then after this loop we increment I. On that process, we'll be comparing each and every term, each and every element to just a single element of this array, or each and every object here in linked list to just a single object, so that we can count the occurrence of that object in the linked list. So how are we going to do it? Here on this for loop, at first integer I is equal to 0. When I is equal to 0, let's initialize count to what? To 0. And then from there we get in the inner loop, the nested loop. We are going to declare what? J and initialize to 0. So when j is equal to 0 and I is equal to 0, what are we getting here? So, and then we are going to use that the if statement. We are going to use this if statement in this get method, and then in the equals method. The get method here is going to get the element at index I from the list, and then it comparing it using the equals method that you use to compare the objects of what? Of list, or of linked list. So we are going to compare it to the element at index j. Like here, at first is equal to 0 and j is equal to 0. So at first we are going to compare this 0, the element at index 0 and the element at index 0. So if we come here, the element at index 0 is 2, comparing it to the element at index 0 again, because it is the same list that we are using. It is the same list, but passing I and j here, but it still is at 0, 0. So is 2 equal to 2? Was is it 2 equal to 2? Was here we having 2 here and 2 here. Is it 2 equal to 2? Yes. So let's increment our count, and then our count will become equal to what? Equal to 1. And then we exit that if statement, and then we exit this for loop, but we are not going to exit it just here, because this for loop, after just execute this count loop, this count statement, we will get back here and increment this j, and now our j is equal to 1, but our I is still equal to 0. So here our j is at 1 here. So index at 0 and index at 1, we compare those two elements, index at 0, is it equal to index element at index what? At index 1 here. 2, is it equal to 5? No. So we are not going to increment this. Since it is a no, we are not going to increment this, and then we will increment this again, and we increment this again, and it will become what? It will become 2. But still our I is what? Is constant, is still at 0. You see, our I is still at 0. Since we are not yet executing this code, this outer loop, we are still in this inner loop until we reach this element. So we compare the element at index 0, which is 2, with the element at index 1, which is 0, with the element at 2, at index 2 here, which is 0, 1, 2, which is 0 to equal to 6. No, then you are not going to increment until we reach this 20, and our count will be still equal to what? Equal to 1. Then you exit this if, and we exit this what? Where when we are here, when we reach this 20 here, we exit this count, and we exit this what? This outer for loop, and then from there we are going to execute this if statement, which says if count is greater than maximum count. Our maximum count, what is the value of maximum count? Initially it was set to what? To 0 here. So is it this count? Now our count is 1, since we have incremented it once. So is it 1 greater than maximum count? Yes. So we will actually take the element at index I. Remember, index I is the one which is keeping track of the number that we are comparing, because we are comparing this element at index I, which is constant, with all the numbers, in the list. Like here, we actually comparing the element index 0 with the elements at index 0 up to the what? Up to the size of the list, which is when we reach the last element. So we are going to take that element at index I, and then we actually cast it to integer. Since this mode is an integer, so you have to cast it to integer, otherwise you will encounter an error. That's why I put this integer. You are casting that variable to integer. From what? From an object to what? To integer, and then we put that value in mode. And then our mode will be equal to 2. Here will be equal to 2. Since our index is what? Is 0, I, there is still 0. And then the max count will be equal to 1 now. You take the value of count and then put it equal to what? To 1. And then from there, since we have reached here, we will loop the outer loop up to here, and then up to here, and then we increment our I, and then our I now will become equal to what? We will be now 1. Our I will be now what? 1 here. When I is equal to 1, we reset the value of count. Since our value of count was now equal to what? Was now equal to 0, we will increment, since our value of count was equal to 1, now we actually reset it, because we have stored the value in max count, so that we can use it in our future. So here we come here and start to do the same procedure. Now j is still at 0. At first our j is equal to is 0. Here our j will be what? Will be 0. And then our I here will be what? Will be 1. So we are comparing, here will be 0. So we are comparing the index 1, which is 0, 1. This is 5. We compare it with what? With the element at index 0. So we will be saying, is it 5 equal to 2? No, we are not going to increment count. Then we compare 5 and what? And 5. Yes, then our count will be equal to 1. Then we compare 5 and 6. No. 5 and 7. No. 5 and 7. No. 5 and 10. No, we are not going to increment this. 5 and 10. 5 and 11. Up to 5 and 20. And then our count will be still equal to what? Equal to 1. And then from there, we are going to check, is it count greater than max count? No, because here we have got 1 and here we have got 1, so we are not going to execute this if loop. And then from there we will loop again, and then our I will be what? Will be equal to 2 now. Then the element at index 2 is what? It's 0, 1, 2. Then you have 0, 1, 2. Then you are going to take this 6. We do the same. And you find that this 15 is our mode. Why? Because this number is going to occur more than any other number in this list. So at the end it will return what? The mode is what? As 15. So I'm just going to show you how is it going to work this out. Let's take this index is what? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Here, let's say our I is now at index what? At index 9 here. Is at index 9. So I've actually jumped some other loops so that I will keep this video short too. So here our index is now what? Is now 9. And the index of J will be actually from 0 up to the size of the list. So at index 0 and 9 here, 0 and 9. Here we've got 9, here we've got 0. We'll compare this 50 and 2, and it will be a no, and here it will be no, and here it will be no, here it will be no, here it will be no, until we counter 9 and 9, where it will be going to be what? To increment this one by 1. After incrementing that by 1, it will also check 15 here. This one, the next element, which is 10, 9 and 10, then it will also increment this one by 1, which will be equal to what? To 2. And then it will increment this one by 1 up to what? Up to 3. And then here it will stay just like what is 3. And then from there, we are going to say if count is greater than maximum count, and the value of maximum count now will be equal to 2, since we have got these numbers which is okay, we have got what? 2 number of occurrence, and this one 2 number of occurrence. So our max count will be now equal to 2. So is it 3 greater than 2? Yes. No. And then the mode are going to be equal to what? The element is index I, which is at index 9, which is what? 15. So our mode is equal to 50, and then is initialized to 15. This is the initialization statement. And then from here, the count, which is 3, is going to be what? Inserted or initialized into what? Into max count. And then from there, we go up to this when I is equal to this what? This index. And then from there, we will return the mode to this statement here, which is here. So we're going to return 15 here as our mode. So I'm going to give you this code. I'm going to give you the link for this code for my Google Drive, but in the near future I'm going to do my website where you'll be actually downloading all these codes from. So team, that's all that I was actually having for you. So I want to say thank you for watching this video. Thank you for being patient enough for me to explain all this concept, for me to explain all this the algorithm, the steps in the algorithm to find the mode in Java. So guys, just subscribe to this channel for more videos. Also, don't forget to turn on the notification bell so that whenever I upload a new video for this Java program, for this Java programs, you'll get a notification from this channel. I want to say thank you for everything. Thank you for being loyal to me. Thank you.